Alright, so now that we have refreshed our memory on how things work in shallow learning with gradient descent, and now that we know the chain rule and how to calculate derivatives of nested functions, we're ready to tackle backpropagation. The network that I've drawn here is basically the network that we used for the I and the B exercise. So just keep in mind, if you make abstraction of what is in the red square here, you have exactly the situation as we had with shallow learning, right? So if this is a black box, you have a data set input, out comes a model. The model you compare with the true y, and you have an error. And that error is again going to be the square difference between y predict and y. And then you have the error as a feedback signals to update your w's, your weights. So here we have three layers. We have A1 and A2 are the activation of layer 1 and 2, which is ReLU, 16 units. And the last one, A3, is a sigmoid function that basically gives you the output if the movie has a positive comment or a negative comment. Now, if you see the first feedback loop here, you see that we're gonna change something here, which is the W3. The W3 and the I3 are then activated by A3 and give Y predict. Just keep in mind that the data set here is fixed, is given. A1, A2, A3 are also given. So the only way you can influence Y predict is through the W's. Yeah? Once, of course, you touch W3, you're going to touch the output of the activation function A2. And if you change the output, you also need to change the input, which is W2. Once you touch W2, you will touch the output of A1. And of course, you will then change W1. So, going back like this is what backpropagation is. And now you can say, well, it's not such a big deal. Why all the fuss here? Well, because of the following. Yeah, so we need to find the W's to minimize the cost function, to minimize the error. And this is our cost function here. And we could write y predict equals, if you look here, y predict equals A3, which is a sigmoid, working on W3 and I3. Yeah, so it's A3 working on W3, I3. Keep in mind, this is not a times operation. This is a function working on a variable. It's exactly the same if you have a variable x and you take f of x. It's the function working on x, okay? Just want to be clear. Now W3, I3, if you look at that, is basically the output of A2 working on W2, I2. Yeah, so W3, I3 is A2 working on W2, I2. And W2, I2 is A1 working on W1, I1. Is A1 working on W1, I1. So you see the result, y predict equals, yeah, you have A3 working on A2, working on A1, and A1 is working on W1, I1. Yeah. So here you can immediately see that this is a nested function, and with pleasure we're gonna apply the chain rule to that. So basically, remember in the shallow learning we had the cost, and here we had the weights. Yeah? But in this case, yeah, the last W3 is related immediately to y predict. But W2 and W1 are a bit further away. Now that's one complication. And the other complication is with my cost function C, I don't have direct access to W3, right? With W3 is nested in the activation function A3. So if I want to go to W3, I gotta go through A3. So this derivative here is the cost function with respect to A3, and then A3 with respect to W3. Yeah? So this is how it works. Yeah? And now, of course, we can calculate the influence on W2 and W1. Yeah? So let's do that. So we have here our input I1, W1, and then you go to the next node. So this is A1, this is A2, and here you have I2, W2. I2 and W2 is the result of A1 working on I1, W1. And then we have our last one, A3, and here we have I3, W3. Yeah. And of course the output here is then what I predict. Alright, so this one we solved already, is the influence with respect to W3. And remember the update rule on gradient descent. So we have the update rule, and that your next point is W1 equals, W2 equals W1 minus alpha, derivative of the cost function in that point W1. So this was the update rule for shallow learning. Well, very similar here, huh? You're going to have minus alpha, you're going to have this derivative, this C dA3, and then dA3 with respect to W3. Yeah, it's just a chain rule. Yeah, so here you have your diagonal. Alright, now we're gonna tackle W2. Yeah, well, W2 I can only access through A2. I cannot access it directly. So I will need to take the derivative of A3 with respect to A2, and then A2 with respect to W2. Yeah? So this looks like this, minus alpha. I keep the C with respect to A3. And now I have A3 with respect to W3. So I have to go to W2, so I gotta take the derivative with respect to A2, and then the derivative of A2 with respect to W2. Yeah? So this with respect to A2, and then A2 with respect to W2. Chain rule. Here we have your chain rule. Okay? So that brings W2 in the mix, or the change of W2, the change of the activation function with respect to W2. So you know derivative is a change. Yeah? And then we have here A1. Yeah, so let me copy here a few. DC, dA3. Yeah. Then we have dA3 to dA2. And then we have dA2 to dW2. Right? So if I want to bring W1 in, I gotta take the derivative of A2 with respect to A1, and then A1 with respect to W1. Yeah? So I need to take the derivative of A2 with respect to A1, and then the derivative of A1 with respect to W1. Yeah? And here is where we bring W1 in. So here again, chain rule. Yeah? Chain rule. Alright, so in the end, if this is your first W3, yeah, this is your W3 minimum, you calculate the derivative, the slope is negative. Negative together with the minus alpha is positive, So you're basically moving in this direction. Exactly the same as we saw for shallow learning. So this would be W3-2. And this will converge with small steps. When you choose alpha to be small, this will converge to the minimum. So your W2, 3, so it's W3 second round equals W1, so it's actually W3 first round minus alpha, and then I have this piece here, dA1, dW1, dA2, dA1, and then dA3, dA2, and then the cost function with respect to A3. Yeah. This is my update rule to go from W31 to W32. All these factors are easy to calculate. The cost function with respect to A3, easy to calculate. Now remember, A3 is the sigmoid function. So it's a function, you can take the derivative. The A3 with respect to A2, you can also calculate. Yeah? Because what you see is here, A3 is a function of A2. Yeah? Easy to calculate. A2 to A1, easy to calculate. You see that A2 is a function of A1. And then A1 with respect to W1, well, easy to calculate. Yeah? Because you have A1 here working on W1. So you can do these updates, yeah, fairly easily. Yeah, we will not have to do this ourselves. Keras will do this for us automatically. But at least I want you to grasp the difference between shallow learning and deep learning. Whereas in shallow learning, you don't have a nested situation. In deep learning, you have a nested situation. And that means that you gotta apply the chain rule in order to see what a change in YP means for your change in your weights.